Now, I do want to just spend another moment talking about Microsoft's global network here. So, we just talked about the 54 regions and how all of these things are available to you in the public cloud to be able to create computing resources anywhere you want in the world effectively for pennies. But how is Microsoft able to do this? Well, over the years, they've invested billions and billions of dollars in these buildings and all this computers and the wiring and all that stuff. Here's a picture, a bit of a slideshow moment here, but here's a picture of a data center in Amsterdam. This is a Microsoft data center in Western Europe here. And you can see all the cooling units on top of it. So inside there are a couple of floors of servers. You go into it. This is in Wyoming here, but you go into it. It's a warehouse just full of servers. And Microsoft has standardized all this hardware. And so whenever they're installing servers and building brand new data centers, they just they know what they're doing. They're building it based on this plan. I saw this picture in my searches here of Microsoft Azure servers that are designed to run in the ocean floor. So this is off the coast of Scotland. They put some servers into this tube and they dip it into the water, plug in electricity and in networking. Now, the advantage of this type of thing is that it's a sealed container. There's no dust getting in there. There's no contaminants of any kind. There's no lights inside. And so those machines can actually just run. There should be no real hardware failures. There's nothing that can get in there that can damage the hardware. They're supposed to be more durable than a regular data center where people are coming and going. The other thing, too, is they can take advantage of the water, the cold water for cooling purposes. So we don't need to run all those air conditioners on top of a building, and that costs money. It has cold water all around it. And so Microsoft is sort of innovating on these types of data centers. Now, the other thing is not just the buildings and the servers, but they've got their own fiber. And so this is not running on the public internet. Actually, Microsoft said, I think it's the largest or the second largest private network in the world. So these lines all represent fiber capacity that, as you can see on the west, all through North America, under the Pacific Ocean, under the Atlantic Ocean, all around Africa, all around Europe, and through Asia. And so these are high-speed, multi-terabyte, multi-petabyte traffics that can travel over the world. And so when Microsoft is dealing between their North American data centers and their European data centers, they're running on their own network. Not only, of course, is it costing them nothing to do that, but it's protected from the travels of AT&T and other providers who are running the public internet. So they're investing in this in many different ways that we don't get to see effectively. One of the things that I saw was they connect like Spain and Virginia for their data centers. Most transatlantic connections are between the UK and New York, right? So they're even protecting regional things in a slightly different way that you would think. So now let's switch it up a little bit and let's talk about the buzzwords effectively. You'll hear these things as being advantages or features of the cloud. And we're gonna just sort of dive into some of these. Now, first concept is the economies of scale. Now, it's just a fact, I guess, that Microsoft can purchase a server, install it, and run it for cheaper than almost anyone else in the entire world, right? They're at that scale where they can run a server for a lot less than you can run a server, okay? This includes not only the purchase of the hardware, because they can go and negotiate. If they're going to go buy 100,000 servers from somebody, they're going to get a really great price that you're not going to be able to get. There was a slide that said they have electricity is about 20% of the cost of running a server on your own. And Microsoft's building data centers next to rivers, and they're being able to draw on the river to power their data center, etc. So all of these ways that Microsoft's getting electricity cheaply. There's certain countries, if you're any familiar with Bitcoin, countries that are known as having cheaper electricity costs, and so Microsoft can install servers and get the absolute lowest rates on electricity. Even the labor costs. Now, you might think, oh, Microsoft's employees are not any cheaper than my employees. Maybe they're more expensive, but you're only running 100 servers. Microsoft's employees are running hundreds of thousands of servers each. And so the cost per server, an employee cost can be distributed over way too many servers. And the other thing you don't really think about on the demand side is the utilization of the servers. And so while you're running servers and you may have daytime and nighttime and certain capacities that go up and down, seasonal, Christmas time versus the summer seasons, Microsoft is able to, because of their global reach and the millions of customers, they're able to manage the demand nighttime, daytime, Christmas, winter, summer, because of the way that the world works. So they're able to get higher utilization rates out of their hardware and manage it than you would out of your hardware. So the first concept we'll talk about is the concept of high availability. Now, you may be familiar with this because it's not just a cloud concept, but it's a concept in general. The availability of a system is basically the percentage of time that whole application, like the thing as a whole, is able to successfully respond to user requests. And so you can use the word uptime as a very proxy or very similar word, but it's not just the uptime of that server. It's the connection to the internet. It's the back-end services, the database that serves the server, the load balancers, and all of the services around it. So it is uptime, but it's not just uptime of a single machine. Now, you might think 90% is a high score, and if you pass your exams, your parents might be pretty proud of you with a 90% grade. But 90% availability in server is not that great. It's literally 2.5 hours of downtime per day. That means you are aiming to, be down from midnight to 3 a.m. every night, and that's not a really available server, right? If you radically scale that up and say, okay, we're going to go for 99% availability, that's still about 15 minutes a day of downtime. I mean, that's basically the time it takes to reboot a server. And so if you said the nature of our server, the nature of our application is that we need to reboot it every day. We cannot function more than a few days without a reboot. So every morning at 3 a.m., we're going to reboot the server. That's technically 99% availability because you can't keep that server running more than, with 15 minutes a day, it needs to be rebooted. So it's pretty good availability. Maybe your customers wouldn't necessarily notice, except if it's like every day in the middle of the day, unexpected, that would be a problem. Now we get to the concept of high availability. So that was just availability in general, but high availability is intentional, right? It's intentionally creating a system that seeks to avoid downtime. And that requires thought, right? That requires planning in advance, and it's not necessarily the cheapest solution. You're going to have to go for higher level, more expensive services from the cloud providers, including Azure. You're going to have to go for duplication, replication, backups, all of this stuff. It adds cost. So to get from, we were just on the last slide of 90 and 99%, now we're talking 99.9. And when we get into these nines, you might hear them referred to as 3 nines, 4 nines, 5 nines. So 3 nines availability is a minute and a half a day. And that's actually pretty good. If your application isn't available from, just randomly from 3 o'clock to 3:01 p.m., you're not really people will deal with that. But that's not necessarily super ideal. We get to 4 nines availability. That's only seconds, right? That is 9 seconds per day. That's very difficult to achieve for 4 nines on a single server because servers need stuff installed. Servers need rebooting from time to time. When you get into 3 nines and 4 nines, you're talking about having multiple copies of your application in different regions, load balanced, etc. Now you might think, okay, my goal is to be 100% available. 100 is the goal. Well, that's sort of a mythical creature. It's like the Loch Ness Monster or a Yeti or something where, you could set that as a goal, I guess, but it's generally not entirely possible. And I say this very carefully because there are companies out there who are bigger than you and bigger than your client, like Facebook, like Google, like Amazon.com retail site, all of these companies who do not have 100% availability. I can remember just over a month and a half ago, Google search being down. I went to google.com and I got an error message. And you stop for a second and go, what? What am I seeing here? Google.com's not available. And then you refresh the browser and it comes back. But that's not 100%. If I get an error from google.com, even if it's just for a few seconds, that's down. And there are times too when we hear about these cloud providers having regional outages. And so Microsoft Azure will occasionally have a bad deployment. AWS will occasionally kill a whole region. And then you hear about these companies like Stripe and all of these e-commerce companies and eBays and things like that having outages because the cloud provider has an outage. And so it's 100% is generally thought to be impossible. And prove me wrong there, I guess. Next concept, we just thought, so that's a high availability. It's intentional, right? But you can't get to 100, but you can get 99, 99.99, 4 nines, 5 nines. Those are attainable. Scalability. Scalability is the ability of your system to handle the growth of the users or the growth of the work for those users. And we can take a graphic like this, really crude graphic that I drew, but you can see that every system has a max capacity. Every system, okay? Even Amazon.com has a max capacity, but Amazon.com sets their limits so high that it's higher than their usual spike in traffic, okay? I worked in an environment once where we did load testing and we, ran a load test against our main website. And then you come back and it says it can handle this many thousand concurrent users. And you find out where that bottleneck is. Is it, in the traffic to the database? Is it in the IO system writing files to the server? Is it CPU? Is it memory? What is the bottleneck? And then you work on that. You run the test again. It's a recurring process to say, what is your bottleneck? But every app has a bottleneck. Every app. Okay. So scaling is not the act of being able to scale, but is it possible? Is it easy? Can you just add a server and boom, you've increased your capacity? So can you increase your capacity? That means no code changes, no refactoring of your code, no re-architecting of your solution. If you can grow your solution, then you can say your solution is scalable.